Admission control is a widely misunderstood topic. Its job is to ensure that upon failures of ESXi hosts, that virtual machines that have reservations set on them will actually be able to start upon those host failures. Now, why wouldn't a VM be able to start? We remember that reservations are guarantees of capacity. If a VM has a reservation for memory that says 64 gigs of RAM, has to be guaranteed to the VM. That means we have to be able to find an ESXi host with enough non-reserved or unreserved capacity to meet that 64 gig guarantee, or the VM won't be able to be restarted. Now, in an HA cluster or in any environment where there's a host failure, all of a sudden, you don't have as many resources as you had before. So can we restart that VM with a 64 gig memory reservation? I don't know. Well, if we're able to set up some rules that says, I'm going to anticipate a certain number of hosts in my cluster that they all might fail, a certain number might fail at the same time. Maybe it's one host will fail. Maybe it's two hosts will fail. Maybe in a 64 host cluster, I want to make sure that an entire blade chassis, say it has 8 blades in the chassis. What if the whole thing fails all at the same time? All 8 hosts go down out of a 64 host cluster. Well, what happens if I'm down 8 hosts and I have reservations on my VMs? Will all of the VMs on that 8 host cluster be able to restart on the remaining capacity? Well, let's ensure that that is true. Let's make sure that we don't reserve more capacity across the entire cluster than we would be able to restart VMs upon failures. Okay, so let's take, say, if it's an 8-host chassis, that's 1/8 of a 64 gig cluster. Let's set aside 1/8 of the total resources of that cluster in the event of a failure. That's what admission control is all about. And if that's the case, we try to power on VMs that would exceed, say, 7/8 of the total reserved capacity, admission control will prevent us from powering on that VM. So it won't allow us to reserve all of the capacity of the cluster. It'll only allow us to reserve as much capacity in the cluster as we would have in the event of a failure. Well, that was a long way of explaining that it sets aside some resources for us so that we can support host failures. Okay? Now, the math behind this, how much unreserved capacity do we need to set aside, can be talked about in a couple of different ways. Okay? We can define host failover capacity by looking at a cluster resource percentage, or looking at something called cluster slots. How many host failures can we tolerate? Okay? Here you can choose how many host failures, and here's how you choose how the math is done. All right, let's look at these two options for how the math is done. The first one is by using cluster resource percentage. So imagine in this scenario, I have 3 hosts in a cluster, and I want to be able to support all of the VMs, powering them back on in the event of one host failure. Well, it stands to reason that I could only allow reservations to consume up to 2/3 of the capacity. That makes a whole lot of sense. Pretty easy to understand. We separate this for CPU and we separate it for memory. Okay? So here, what we'll do is we'll set it not to 30%, we should set it really to 33% that we'll set aside, 33.3, maybe even 34% that we set aside to ensure that in the event of one host failure, we'll be able to restart the VMs. That's how we do it by a percentage. And this works really, really nicely, and it's the default, and for the most part, you shouldn't change this value. This is how we want to calculate it. The other option is by using slots. Now, this is a little bit complicated to explain. Imagine it's like this, and I'll try to explain this as best I can. I've got a big, giant parking lot at some sort of amusement park. Okay? And in this big, giant parking lot, we have just repaved it. And it comes time to paint new spots for vehicles. And so somebody says, hey, how big should these parking spots be? And the answer to that question in this case is we want these parking spots to be as large as the largest vehicle, as large as the largest reservation on our virtual machines. The width is equal to the CPU reservation. The length is equal to the memory reservation. So find the VM, find the vehicle who's widest, and paint all of the parking spaces that wide. Find the vehicle that is longest, and paint all of the parking spaces that long. Now, how many parking spaces are available in my cluster? Okay, good question. In this case, we are creating, based on 3 hosts with 6 gigahertz of CPU and 8 gigs of RAM. We're looking at the virtual machines and their reservations. We find a virtual machine with a 2 gigahertz reservation for CPU, and we find a virtual machine with a 2 gigabyte of memory reservation. If you do the math, that allows us to run 2 by 2, 9 or 6 VMs on each host. Why? Because it's, 3 VMs on each host. Because for CPU, I can support 3 of these. For RAM, I can actually support 4 of these. CPU is the limiting factor, so we're only going to allow 3 VMs to be powered on each host. Now, I want to support the failure of one of those. Can I run 9 total VMs in the cluster? No, I can't run 9 total VMs in the cluster. Okay? I need to be able to set aside an entire host's worth of slots. That would only be 6 VMs I could run in the entire cluster. Now, that's kind of inefficient in this case, because we have 18 gigahertz for CPU, we have 24 gigs of RAM, and I'm only going to run 6 of these little VMs in the cluster. It would seem that this method of calculating the failover capacity for the hosts is a little bit inefficient. And honestly, it's true. Using admission control by using slots is an inefficient method of calculating the total capacity of the cluster, because in many cases, the reservations on your virtual machines are not equal to one another. If they were all identical VMs with identical reservations, then yes, it would be the exact same way that we would calculate it using percentages, okay? But because that's not always the case, percentages is really a better way to do this. I can tell you that admission control using slots was the original admission control algorithm, okay? The percentage was added a little bit later, and the default became percentages right around vSphere 6.5, okay? Long and short of this, by the way, just leave the defaults. Let it calculate using slots. By the way, this admission control is a very important thing. It ensures that the virtual machines will be able to be powered on. But if we don't use reservations at all, then admission control using slots or percentages, it all goes out the window, because we can power on VM after VM after VM after VM, and if they don't have any reservations, ESXi will allow them to power on. But that doesn't guarantee any sort of level of performance at all. Okay? So using reservations to guarantee virtual machines a certain level of performance is a great idea. But how many of us in practice actually do that? Well, I actually hope you do use reservations, but I can tell you from experience that most of us do not. So in vSphere 6.7, we added a new feature to admission control. And what this says is, am I going to allow the performance of my VMs to degrade in the event of a host failure? After all, if I haven't set reservations, that tells the system, I don't care what the level of performance is, just fire them up. Get them powered on, even in the event of a failure. If I have a 10-host cluster and 9 of the hosts power on, heck, throw all of those 9 of the hosts fail, throw all of those VM on the one remaining host. Now, what kind of performance am I going to get? It's going to be awful, okay? But because I didn't set any reservations, it told the system I didn't care. But of course, I do care about that. Well, this new setting allows me to, at the very least, set up a warning system that in the event that there is a possibility of failure, there is a degradation in performance, it will warn me. So during normal operating conditions, if my load goes so high that if there were a failure, we'd have contention, I can know. Great, I'd like to see that. This is a nice new feature and it's set up right here. The default is 100%, and it actually says, I'm gonna disable the warning. I don't care if I lose performance. But you can set it at 50%, and it will give you a warning if the performance of your VMs were to decrease by more than 50%. If you set it at 0%, that sets up a warning if during the event of a failure, and you can say how many host failures you want to support here. In the event of a host failure, that my VMs perform any differently at all. If there's any performance degradation, warn me about it, okay? So this is really nice in the event that I don't use reservations in the environment, okay? It'll warn me if in the event of a failure, there will be performance problems. I really, really like that. When we come back, we're going to look at some of the other options that we have as we continue to set up our vSphere HA cluster.